right, let's take a look at doing a little bit more with Taylor series. First thing is, a lot of times on the AP exam, they will ask you to generate terms. They'll say find the first 4 non-zero terms or something like that, and the general term of a Taylor series. The general term, don't be intimidated by it. This right here, just the expression for the sequence. So like with e to the x, it's x to the n over n factorial. That's the general term of e to the x. The best way to do this, to get these non-zero terms for this random series, is manipulate the general term and then generate the terms after that. So like you could create the first 4 non-zero terms for the original and manipulate those terms, but I just think it's easier to find your new general term and then plug in n equals 0, 1, 2, 3, etc. until you have 4 non-zero terms. So let's go ahead and do that. Find the first 4 non-zero terms in the general term for the Maclaurin series for x e to the 2x. So to do this, I'm going to start with the Maclaurin series for e to the x. So there's my Maclaurin series for e to the x. The first thing I do, because I'm really just thinking order of operations, is I need to make that a 2x. So I just replace x with 2x parenthetically. And you can leave it like that if you'd like. I think that to generate terms, you'll have an easier time if you apply the exponent to each individual term, or each individual factor. So 2 to the n, x to the n, over n factorial. And now I need to throw that x on it. So x e to the 2x would be equal to the sum from 0 to infinity. I'm going to take this one. X times 2 to the n, x to the n, over n factorial. And again, your life is going to be easier if you just go ahead and simplify it. So 2 to the n, x to the n plus 1, over n factorial. So that is how we would create the general term. Now it says also find the first 4 non-zero terms. So that means I need to generate terms. That doesn't mean you can't plug in n equals 0. It's just if you plug in and get 0, skip that one. So I'm starting at n equals 0. I'm going to plug in 0, 1, 2, 3 until I have 4 terms. So I have 2 to the 0, x to the 0 plus 1, 0 factorial. There's my first term. 2 to the 1, x to the 1 plus 1, 1 factorial. 2 squared, x to the 2 plus 1, 2 factorial. You're just going to pretend that's a 3. And then I'll put plus dot dot dot. If you don't put the plus dot dot dot, as petty as it feels, you're wrong. Because it doesn't stop there. It keeps going. I can simplify those like this. Four thirds. I did that very fast, but 2 cubed is 8, 3 factorial is 6, and that's simplified to the 4 thirds that I got. Plus dot dot dot. So this is perfectly fine right here. In answer keys, you might see something different, but general term is there. First 4 non-zero are there. I'm good. I've done what I need to. So they might also ask you to go the complete backwards way. They'll give you a Maclaurin series or a Taylor series or something like that, and they'll say, what function did you start with? So for example, I've got 1 minus x squared over 6 plus x to the 4th over 24 minus dot 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 plus. And then here's my general term. That's really where you're going to figure this out. You're going to look at the general term. And the factorials are the giveaway. I want to figure out what function is represented by this general term. Look at the factorials. So for example, this one, it's got 2n plus 1 factorial in the bottom. I know it's got something to do with sine of x. Sine of x is the one that has 2n plus 1 factorial in it, right? So if I think about it again, e to the x, I'm not going to write the whole thing out, but there I'm looking for n factorial. Cosine of x, the general term is negative 1 to the n, x to the 2n, 2n factorial. Sine of x, its general term is negative 1 to the n, x to the 2n plus 1, and then 2n plus 1 factorial. And then finally, 1 over 1 minus x. It's the only one that doesn't have any factorials, out of the ones we memorized at least. There are many Taylor series that don't have factorials, but the 4 that we memorized are those. So if I see 2n plus 1 factorial, out of those general terms I have memorized, there's only one that has 2n plus 1 factorial in it. So this function has something to do with sine of x. Now, I don't know exactly what, but... Now, again, remember, this is supposed to say 2n plus 1 if it's a sine function, right? Well, there's only one way I can decrease a power. I must divide it by x. That's how you decrease a power. And that's it. That's the answer. I could tell it was sine because of the 2n plus 1 factorial, and I needed to decrease the power, because in the normal sine, it's 2n plus 1. So I just divided by x. That decreases the power for me. Find the sum of the series. This is the same exact question, but a different phrasing. So, what function is represented by the series below? Find the sum of the series below. They're saying the same thing. Now here, the factorial I notice is n factorial. That makes me think e to the x. But e to the x doesn't have that plus 1, right? So how do they increase the power? They must have multiplied by x. That's it. Interestingly, I can also look at some series that have numbers now, and I can find their value just because I know they're a Taylor series representation, right? So this series, 1 plus 2 plus 2 plus whatever, general term, you had 2 to the n over n factorial. Oh, I could tell it converges because factorial on the bottom probably converges, but I wouldn't have been able to tell you its value until now. That n factorial on the bottom makes me think of e. Right? That makes me think e to the x. But it's not x to the n right here, right? It's e squared. So this must be e squared. The value of that series, the sum of that series, is just e squared. Kind of cool. So then the same idea here. I see the 2n plus 1 factorial. Makes me think sine. The exponent's right. Well, then the sum of the series is just sine of 3. Right? Because right here, there's a 3 instead of an x. And that's kind of it there. I think I got one more. Nope, I have a blank slide here. Bye!